All right, so welcome to the Zoom class summary for December 2nd, Wednesday's class. So this is for if you missed Zoom class or if anything was lagging. A couple of general announcements, mainly one that you have your quiz on Friday. So if you check on your Schoology page for medical chemistry, on the right-hand side here where it says Unit 2 Open Notes Quiz on Friday, December 4th, and you click on it, here's the link to your Unit 2 study guide. All right, all of the Nearpod lessons we've covered in the past here are before. Below is kind of what your quiz will look like in terms of practice problems. And if you click up at the very top of the document where it says click here for answer key to study guide, you will find a link to the answer key. All right, so a reminder that your quiz is coming up on Friday. And I'm also going to do one-on-one check-ins with those of you who are struggling in this class to help you catch up. All right, so please, please, please come to class on Friday. I will check in with you, and then life will be easier, hopefully, and less stressful. Okay. So today we're reviewing Nearpod Lessons 3.4 on the Bohr model. So if you were not here on Tuesday or did not complete your Nearpod Lessons 3.4 yet, please do that first. So to do Nearpod Lesson 3.4, you're going to go back onto your main page in medical chemistry. And I think the fastest way is if you just click on the calendar up here or through your grades, but I don't want to show other people's grades, so I'm just going to click on the calendar. Right. And the homework due today was lesson 3.4. So if I just click on this, the link to lesson 3.4 is in step number 1. Right. Know that this is true for all of your homework. So anytime you're missing homework and things like that, they're all linked in the calendar for your other classes too. All right, so once you've completed that Nearpod lesson, it doesn't matter which class I click on, you should be ready to complete the launch. If you're kind of struggling with the lesson, like you're still kind of confused by it afterwards, towards the second half of this video, I'm going to go over the questions from the link launch check-in. All right, so I'm going to go over questions from this one, and this will be your launch to do the actual launch practice. All right. I noticed that when I was checking your Nearpods from last time, that a lot of people were struggling with how to find how many neutrons and how to draw electrons. So I left a Bohr model extra practice for you to do on scratch sheet of paper if you would like, along with the extra practice answer key so you can check if you're correct or incorrect, right? But right now, I'm going to go over this pre-launch check-in since I noticed a lot of students were struggling with this, right? But feel free to take this first just to see if you can do well on this. And if you do well on this pre-launch check-in, you should be able to do the launch very successfully, especially if you get 4 out of 4. If you miss question number 2 and 4 especially, the launch might be hard for you, right? And then feel free to skip to certain parts of the video that you find more helpful than others. So go a little slow in this video just in case anyone needs a clear description. But if you already get certain things, feel free to skip to the part of the video that you need. So question number 1 asks, for this element that Ms. Kwan made up, how many protons does this element have? So to find protons, it's our top number, right? So this is going to be elements with 17 protons. The top number tells you how many protons you have. Most people got that after Nearpod lesson 3.4. So here's one that a lot of people missed, right? For this element that Ms. Kwan made up, how many neutrons does this element have? Right, so to solve for neutrons, it's a little bit trickier. I need to remember that this top number is the number of protons, right? And as a side note, you should also know that the protons will tell you the type of atom or what element it is. Right. So if I ask you, what is this element, just look for the number of protons, and that will tell you what element it is. Okay. So here it's asking, how do you solve how many neutrons this is? So that has to do with this bottom number here, because this bottom number represents the mass of the atom or the atomic mass. And the mass of the atom is made up of two things added together. It's made up of the number of protons and the number of neutrons. So let me clarify what I mean by that plus sign, because I just drew the symbol for protons and the symbol for neutrons. Whoops. So the atomic mass is protons plus neutrons together, right? So when I'm trying to solve and figure out how many neutrons I have, we're going to have to do a little bit of algebra. So one of the things I'm going to need to do is round this number to the nearest whole number. So that means I'm going to keep this and ignore things back here. But to help me round, I have a rhyme to help me remember how I should round. So if I'm rounding to the nearest whole number, and the next number after that, in this case, it's 0. So if the number after that is 5 or more, you're going to add 1 more. This means that if this was a number 5, 6, 7, 8, or 9 in the area that I circled, then I'm going to add 1 more to 67, making it 68, right? But in this case, I have a 0. It is not 5 or more. It is 4 or less. So if it is 4 or less, you're going to let it rest. Meaning if this number that I circled here is 4, 3, 2, 1, or 0, I'm not going to change this number. The mass is still going to be 67. All right, so 67 plus the number of protons that I have, 17, and the number of neutrons I have will add up to 67. So some of you can look at this and be like, oh, okay, I think I can figure out how many neutrons I have. And some of you might look at this and be like, I have no idea how to figure this out, right? And that's okay. So let me go over this if you don't see how to figure out how many neutrons you have yet. So basically, if my atomic mass is made up of two things, protons plus neutrons, then I just need to subtract, right? So 67 minus 17 protons will tell me how many neutrons I have left, right? So in my calculator, if I type in 67 minus 17, I will have 50 neutrons. So my neutrons is going to be 50 in this case. right? Okay, so let's go ahead and move on to question 3. And again, feel free to pause this video at any point to take notes down. Or if this is confusing, feel free to email me if you have any clarifying questions. All right. So question number 3, for this element that I made up, how many electrons does this element have? Ooh, let me change the color to red. So for electrons, you'll notice that it is the same number for protons because we're only dealing with neutral atoms. So this is how many electrons I have, and this is only true if the atom is neutral. And in semester 1, we're only going to work with neutral atoms. In semester 2 or quarter 3 or 4, we're going to talk about like what is a neutral atom versus an ion, right? So for electrons, this happens to be the same number as protons. And remember that protons tell you the type of elements it is. Okay. So in this case, how many electrons does this element have? It has 17 electrons because that's my atomic number up top. Okay. Okay. So when you get to question number 4, this one is the hardest one that I saw most people struggling in their Nearpod lessons, right? So for this element that I made up, how many electrons will be in the outermost ring? And my hint to you is to draw the Bohr model on a scratch sheet of paper first. So I summarized what we did in questions 1, 2, and 3 and added this side note. So if you want to pause the video right now to write this information down and then unpause when you're ready, that would be super helpful. Okay, so I'm going to go over this. When I'm drawing the Bohr model, remember that at the center of my atom, I have protons and neutrons. So here I have 17 protons. And as I figured out earlier in question number 2 of the video, we have 50 neutrons for this one. Okay, so here is the center of my atom. But what I really care about is the 17 electrons here. So I know I need to draw 17 electrons. But the tricky thing is that a certain ring, each ring only holds a certain number of electrons, right? So drawing this first ring, I can only fit 1, 2 electrons. So I know that there are 17 total that I need to draw, right? And the first 2, I drew 2 electrons. I'm going to write E minus, short for electrons, in the first ring. Right? But if I draw 2 electrons, I still need to draw 15 more, right? So therefore, I need to draw a second ring to fit my other electrons. So in this second ring, I can fit 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So in this second ring, I can fit 8 electrons. So here I've drawn 2 plus 8 electrons, giving me 10 electrons. But that means there are 7 more that I need to draw, right? So in that third ring, even though it fits 18, I only need to draw 7 electrons in the third ring, right? Because if I add all this up, 2 plus 8 plus 7 will add up to the total of 17 electrons that I need to draw. Right? So therefore, in this last ring, I will have 1, 2, 3, 4, 5, 6, 7. Right? 7 electrons in the outermost ring. Because in the first ring, I can fit 2. The second ring, I can fit 8. That totals up to 10. But I need to draw a total of 17 electrons, as noted by the top number here. So since I only drew 10 in total in the first and second ring added together, the 7 electrons that I have left to draw will all go in the last ring, because in the last ring, the third ring, I can fit 18. Right? And at this point, you should be able to complete the launch. If you forgot where it was, in your yellow December 2nd Wednesday class materials folder, the link to the launch is here.